The lesson we're covering in this video can be found in the second 9 weeks. So if you look at your big pictures, in Unit 6, the second lesson actually involves 4 days of material. And the particular lesson we're going over in this video is going to be the second of the 2 worksheets involved in this lesson. And this complete lesson is titled Solving Exponential and Logarithmic Equations. But again, this is the second of the 2 worksheets that we will be completing in that lesson. And this one's called Solving Systems of Exponential and Logarithmic Equations. So the first 2 problems, we're going to go over the first 2 problems, and then y'all are going to do the rest in your small groups. But the first 2 problems, they say, solve the system algebraically. So if we were to solve this system algebraically, we need to either do elimination or substitution, something like that, in order to solve for the x and y. This first example is probably easier to do if we do it by elimination. We can either eliminate the x's or the y's. Since these x's are almost opposites of each other, we could simply multiply the second equation by a negative, which is just simply changing the sign of each term, and then adding those up. Try that again. And so that will give us 4e to the y equals 2. And then we can just start solving it from there. So we have e to the y equals 1/2. And then we have y equals, to get rid of the e, remember you have to do an ln. So ln of 1/2. Then we can simply plug this into one of these equations, doesn't really matter which one, and solve for the x. If we choose the second equation, going back to the original version of it, it would be 2e to the x minus e to the ln of 1/2 equals 3. So to solve now for the x, we need to simplify this. E to the ln of 1/2, the e and the ln will cancel each other out, and we'll be left with 2e to the x minus 1/2 equals 3. And then continue to solving. This is 6/2 plus the 1/2 will be 7/2. Multiply by 1/2 on each side, you get 7/4, and so x finally equals the ln of 7/4. So the actual point now where they intersect is ln of 7/4, ln of 1/2. So that's where these 2 equations intersect. Now in part B, it says solve for y in each equation and state the domain of each equation. I typically would not make my students do that, but if you choose to do so, let's actually see what that looks like. So the first equation, we have 2e to the x plus 3e to the y equals 5. So if I want to solve for y, let's move the x's over, and so this will be 3e to the y equals 5 minus 2e to the x. And then we can divide by 3. I'm just going to go ahead and shortcut this a little bit. And then again, to get rid of the e, we will ln both sides. And that will give us y on this side equals ln of all this stuff. So there it is, solve for y, and then it says it wants to find the domain. Well, the domain, remember, you cannot take the logs of any negative numbers or 0, so this on the inside has to be positive. So that would be 5 minus 2 e to the x over 3 has to be positive. And so if you try multiplying by 3 to get rid of it, it'll just zero out. So we can just simply bring the 2 e to the x over. And then solve. So divide by 2. And then we can ln both sides. So you could say this is your domain, that your x's have to be less than ln of 5/2, or if you want your students to write that in interval notation, it would be negative infinity to the ln of 5/2. And then with the second equation, very similarly, you would do 2 e to the x minus e to the y equals 3. Probably easier to just bring this 3 over and take the e to the y to the right side and then ln both sides. So there's that equation solved for y. And now we need to find the domain. And again, you would set the inside of this ln, the natural log, you would set the 2 e to the x minus 3. You would let it be greater than 0. And so e to the x would be greater than 3/2. And x would have to be greater than the ln of 3/2. So this would be the domain if you want to write it in inequality notation, but if you want to write it in interval notation, it would be ln of 3/2 to infinity. Now part C to this problem, or to the directions to these problems, say we need to use the graphing calculator to verify our answer graphically. So we need to know what ln of 7/4 and ln of 1/2 are going to be as decimals, and you can use your calculator to do that. But then to actually put them into the graphing calculator and solve them graphically, you would need to use this equation and that equation, and let those be your y1 and y2, and see where they intersect each other. So let's go do that now. Okay, so to put those equations in our calculator, we need to press the y equals button. And then for y1, we can do ln, make a fraction, type in the rest. So there's our y1, and then in y2, we'll do and if we want to see where they intersect, you may want to make sure your window is reset when you graph it by hitting zoom 6. And then you can stop it from graphing by hitting the on key, because we really want to figure out what the intersection point is. So hit second, trace, and then number 5 is the intersection. Then you can let it graph. And when it says first curve, just hit enter. Second curve, hit enter. So you may have to move over a little bit. And then you could hit enter, and then when it says guess, just hit enter again. And there is the intersection point. And so you can write that down in decimal form, and let's see if the ln answers that we had match up. So just some more little tricks you can do. You can hit second quit, pull up what your x was just then, and then what your y was by doing alpha trace y1 of x. So that's what our two values were. And now let's enter in what we got from our answers when we worked it out by hand. We have the x-coordinate as being ln of 7/4, which is the same thing as our x, and then we got our y to be the ln of 1/2, which is also what the calculator gets. So that's a way that you can verify that we had the right answer to the equation. Now let's go back and look at number 2. So the directions for number 2 are just like number 1, where they want us to solve it algebraically and then solve each one for y, state the domain, and then in part C use our calculator to verify the solution. I'm just going to do part A of solving these algebraically, and then I will do one of the equations solving it for y just to show that process. So since we want to solve this algebraically, we can do elimination again, and what we can do is, in this one it looks like it might be easier to eliminate the y's, so we can multiply this second equation by a -2. And if we do that, let's keep the first equation like it is. And then we're going to have -6 ln of x minus 4 ln of y equals -6. Now these are going to cancel out and leave us with -4 ln of x equals 1. And so ln of x will end up equaling -1/4. Then to get rid of the ln, you would exponentiate both sides with the base e. And so that gives you x equals e raised to the -1/4 power. We can go plug that back in to either one of these x's in the original equation. Let's use the second equation again. So that would be 3 ln of e to the -1/4 plus 2 ln of y equals 3. The ln and the e will cancel each other out, and so that'll just leave us with 3 times the -1/4, which is -3/4, plus 2 ln of y equals 3. And then we would need to bring the 3/4 over, and that will leave us with 2 ln of y. This is 12/4 plus the 3/4 is 15/4. And when you divide by 2 or multiply 1/2, you get ln of y equals 15/8. And so that lets you know when you e both sides, or base e both sides, you get e, or y. Let me erase that. So you'll get y equals e to the 15/8. So the solution to this is going to be e to the -1/4 and e to the 15/8. Now, if you want to solve one of these for y, let's just pick one. Let's say we solve the second one for y. So let's start off with what it has, which is 3 ln of x plus 2 ln of y equals 3. If I want to solve for y, I'm going to bring the 3 ln of x over, so that'd be 2 ln of y equals 3 minus 3 ln of x. We would divide by 2, so we would just get rid of that by dividing all this by 2, and then again you get rid of the ln by base e'ing both sides, so it'll be e raised to the 3 minus 3 ln of x all over 2. And then to find the domain of this is the only problem area is right here where the log is, and you cannot take a log. Remember, logs, you can only take logs of positive numbers, so that means the domain right here is x's have to be greater than 0 or 0 to infinity if you use interval notation.